Dear students, in the previous class we studied about functions, types of functions. In the types of functions, one function and one two function and bijective function. We solved some problems also. Now today we shall study about composition of functions. Composition of functions. Here first we see the definition of composition of functions. Let f be a function from a to b and g be a function from b to c. There are two functions. First one is f from a to b and g is a function from b to c. Then composition of G, composition of F and G, denoted by G naught F or G composition F. It denote F and composition of F and G like G naught F. G here. It's a G composition F is defined as the function G naught F or decomposition F from A to C given by G naught F is equal to Ix and F naught G is equal to Iy. Then here G naught F of X is equal to first we studied about function G naught F of X is equal to here first G naught F find out G naught F is equal to G of F of X. Yeah. G naught F is equal to G naught F of F is equal to G of F of X. G is the function of F of X. F is the function of X. F is the function of X. Here G is the function of F of X. This way. Here composition of function means here two functions. One is F is function from A to B and G is another function from B to C. Then composition of F and G denoted by G naught F is defined as the function G naught F is equal to is function G naught F is a function from A to C. Here A is a function, another definition, another C. A, B, C. Here G. Here it is G naught F function. Here it is the X. It's the f of X. It's G of F of X. Here is F is a function from A to B and G is a function from B to C and G naught F is a function from A to C. G naught F is a function or G composition F is a function from A to C. This is the composition of function. Here two functions. One is F from A to B. Then second function is from B to C. Then only we call it as the composition of function from A to C. G composition F is equal from A to C. A to C. Given by G naught F is equal to G of F of X. Here again F naught G is equal to F of G of Y. Then on composition of functions we solve. You already solved some problems, but I once again record one problem or one or two problems. Example 1. Find G naught F and F naught G or F composition G. G composition of F and F composition of G. If F is a function from R to R and G is a function from R to R are given by F of X equal to cos X and G of X equal to 3x square. Show that G naught F or G composition F is not equal to F composition G. First, we observe this one. Find G composition F and F composition G. The functions are one is F from R to R and another function also G from R to R. Means here domain and range from R to R are real functions, real number set. First we find G naught F, which is equal to, we already know, G of F of X. Here F of X equal to here G of F of X equal to cos X. We should write F of X equal to cos X and G of X equal to 3x. 3x square. These are given two functions. Here G of F of X equal to G of cos X. G is a function which is 3x square. We put the cos X in X. Substitute cos X in place of 3 into cos X square. Here G is a function of F of X. We put F of X is equal to cos X. Then G of cos X means we substitute cos X in G of X function, which is 3x square. We put cos X in place of X. Replace X by cos X. Then it's square, which is equal to 3 cos square X. Then we find F naught G or F composition G, which is equal to, like that, we write it as F of G of X. F of G of X. Then which is equal to F of G of X is equal to 3x square. 3x square. We substitute 3x in F function. F of X equal to cos X. We substitute 3x square in place of X. Therefore, which is equal to cos of 3x square. Cos of 3x square. Here, G naught f or decomposition f is equal to 3 cos square x, and f composition of G is equal to cos of 3x square. These are two. F naught G and G naught G f are not equal because we find the value of x equal to, when x equal to 0, G naught f is equal to 3 cos square x, put 0, 3 cos 0, cos 0 whole square, 0 cos 0 is 1 square is equal to 1, is equal to 1 into 3. F naught G, when x equal to 0, F naught G or F composition G is equal to cos of 3 0, x equal to 0, 3 into 0 is 0, it's equal to cos of 0 is 1. Here 3 is not equal to 1. 3 is not equal to 1. Therefore, F naught G is not equal to G naught F. Therefore, G composition of F is not equal to F composition of G. First, you have to find G naught decomposition of F and F composition of G. Sometimes you putting the value here, sometimes confusion. First you know here, first f G naught f is equal to G of f of x. Put the value of f of x here. Which is the f of x? It's cos x. Here, f composition of G, f of G of x. Here, f of G of x is 3x square. Here, we put the value of 3x square in f function. It's a f function is cos of x. We replace x by 3x square. Here, we replace x by cos x. Therefore, here cos x square. Therefore, it's 3 cos square x. We find the value of x equal to 0. G composition of f is equal to 3. F composition of G is equal to 1. Therefore, they are not equal. Therefore, the G naught or decomposition f is not equal to f composition G. First, you clear about one problem, then you can solve other problem also. First, clear. Here, this is the 3-mark question. In every question paper, 3-mark question will ask. Sometimes it will ask 2-mark question also. In the if it is 2-mark question, find G composition of F and F composition of G. Then show that G naught F or decomposition of F is not equal to F naught G also given. Then it's a 3-mark question. There are 3 questions are in the exercise. You practice these 3 problems. Another one I will solve here. This side. Find G composition of F and F composition of G. If f of x equal to 8x cube and g of x equal to x to the power 1 by 3. X to the power 1 by 3. Here also we find decomposition of f. Here g of f of x then is equal to g of f of x is 8x cube. Then put the value of 8x cube in g of function, which is x to the power 1 by 8x cube to the power 1 by 3, which is equal to 8 is the 2 cube. Therefore, 2x whole cube to the power 1 by 3. You know about a to the power square to the power 1 by 2. You multiply these two. 2 into 1 by 2. In the same way, we multiply this one. 2 to the power x. We get 3 into 1 by 3. We get 3, 1 by 3. 3 cancel. Then we get 2x. Is the decomposition of x. Then we find the f composition of g, which is equal to f of g of x. Here, f of g of x is x to the power 1 by 3. X to the power 1 by 3. Then it is equal to f is the function 8x cube. Then we put 8. Put the value of x to the power 1 by 3 in place of x. In place of x. Therefore, x to the power 1 by 3 to the power 3. We replace x by x to the power 1 by 3 to the power 3. Therefore, here also 3 cancel. Then the value is 8x. Here, decomposition of f is equal to 2x and f composition of g is equal to 8x. Here also, decomposition of f is not equal to f composition of g. Yeah, from 1 and 2. From 1 and 2, we get decomposition of f is not equal to f composition of g. It's also very important problem. Many question papers and old question papers ask this question. It's many times repeated. Then we find one more problem. Sorry. If the function is function f from R to R, yeah, we read as f is a function from R to R be given by f of x equal to x square plus 2 and g is a function from R to R be given by g of x, which is equal to x divided by x minus 1. Where x is not equal to 1. You know, if x equal to 1, it's not defined. 1 minus 1. Therefore, we write that x is not equal to 1. Find f composition of g and decomposition of f. And hence, G of 2 and decomposition of f of minus 3. First, we find decomposition of f, which is equal to g of f of x. Here, g of f of x is equal to x square plus 2, which is equal to g of x square plus 2. We replace x by x square plus 2. X square plus 2 divided by x square plus 2 minus 1, which is equal to x square plus 2 divided by x square plus 1. Here it is g naught f, g of f. Then find the value of g naught f of minus 3. We find the value of this also. G naught f or decomposition of f of minus 3, which is equal to, here substitute minus 3 in place of x. Therefore, minus 3 square plus 2 divided by minus 3 square plus 1, which is equal to 9 plus 2 divided by 9 plus 1, which is equal to 11 by 10. Yeah. Decomposition of f is equal to x square plus 2 divided by x square plus 1. Then decomposition f of minus 3 is equal to 11 by 10. Then we again find f composition of g, which is equal to f of g of x. Then which is equal to f of g of x is x of x minus 1. Here we put the value of x by x minus 1 in f function. F is the function of x square minus x divided by x minus 1 whole square plus 2, which is equal to x square divided by x minus 1 whole square plus 2. Here, which is equal to x square. So, then we find g f of f composition of g of which one is 2, which is equal to 2 square divided by 2 minus 1 whole square plus 2, which is equal to 4 divided by 2 minus 1 is 1 plus 2, which is equal to 6. 4 plus 2 is equal to 6. Here we find decomposition of f, and we know about the decomposition of f of minus 3 and f composition of g and f composition of g are 2 also. Here decomposition f of minus 3 is 11 by 10 and f composition of 2 is equal to 6. Yeah, we learn about the composition functions. F composition of G and G composition of F. Then we shall study about invertible functions or inverse of a function. then inverse of a function. Here also a function also having a inverse. We shall study about inverse. Which one is the inverse of a function? A function f from x to y. A function from x to y is defined to be invertible. If there exists a function g from y to x. Yeah, f is a function from x to y. There exists another function g from y to x, vice versa. It's from x to y, it's from y to x, such that g of f is equal to ix and f of g is equal to I. Well, it is an identity of x and identity of y. A function f from x to y is defined to be invertible function if there exists another function g from y to x reverse, such that decomposition of f is equal to identity function, then f composition of x and f composition of g is equal to identity function of y. Then we call it as f is invertible with g and g is invertible with f. The function g is called the inverse of f, and denoted as f inverse is equal to g. F inverse is equal to the function g is called the inverse of f. Inverse, we can write it as f inverse is equal to g is a minus 1. F inverse is equal to g. If the function f is invertible, f should be 1 function and onto function also. Then only the function is invertible, because a function is x, is y. Here a, b, c are function elements, and here also x, y, z. If it says if every element of A should have only one image in Y. They have only one image in Y. And every elements of Y should be the images of any element of X. Then only the function is invertible, because A having Y. Here R is equal to, or function is equal to AY and BX and CZ. The function. F is a function. The elements A having an image y, B of domain x, from B having an image x, and C of domain x having an image z. Here every element of x having a symbol. Here F inverse, which is equal to its reverse. G is a function from y to x. Here it's reverse, x b or y a x b and z c. It's the F inverse. Means G. The G function is from y to x. Here y to x and x to y be a function if it is one and onto also. Then only we call it as invertible function. Therefore, the two functions are invertible. The function is one and onto also. Its corners also true. If a function is one and onto function, the function is invertible with G. So, if we solve some problems on this, if you try to solve this type of problems in two types. If a function is one and onto, then we call it as the functions are two functions are invertible. One function is invertible with another function. Or we find F composition of G and G composition of F. If we get identity element, then we call it as invertible function and find the inverse also. We solve this type of problem here. First we solve one simple problem like example 1. Let S is equal to 1, 2, 3. Determine whether the functions f from S to S defined as have inverses. Find f inverse if it exists. Some problem are given here. F is equal to 1, 1, 2, 2 and 3, 3. Here S is a function. S is a set having the elements 1, 2, 3. F is a function from S to S. Here, F is a function having the ordered pair 1, 1, 2, 2 and 3, 3. Here, all elements of S having an image, separate image, distinct elements of S having the distinct images. Here 1 to 1 and 2 to 2, 3 to 3. 1 is the image of 1 itself, 2 is the image of 2 itself, and 3 is the image of separate image. Therefore, it's a one function. And 1, 2, 3 of S are the images on the domain 1 to 3. All are images. Therefore, range is equal to codomain. Therefore, the function is 1, 1 and onto. If the function is 1, 1 and onto, then it is an invertible function. It's a bijective. It's a 1 1 and 1 2 function. Therefore, F inverse is equal to, here we reverse, right, reverse. Here it is also equal here. This is also F inverse. We can write F. The function is 1 1 and on 2. Then only we write F inverse. Then another also here given is 1 2 2 1, 1 2 2 1 and 3. Here you check this one. 1 2 having the image, 1 having the image 2, 2 having the image 1 and 3 also having the image, because F of 2 having image 1 and F of 3 also having the image 1. Here F of 2 is equal to F of 3, but 2 is not equal to 3. 2 is not equal to 3. Therefore, its function is not 1 1. If the function is not 1 1, it's not an invertible function. If the function is 1 1 and on 2, then only it's invertible. But here it's 1 1, not 1 1 function. It may be 1 2 or not. Here it's on 2 is also not there, because 3 is not an image here. 3 also not an image. That is not 1 1 and not 1 2. Therefore, the function is not invertible function. Therefore, F inverse not existing. It's a 1 or 2 mark questions, or sometimes ask in the 1 mark question also. You practice yourself or perfect about the composition functions and invertible functions. It's all some like this type of problems. Then second problem, if f of x is equal to 4x plus 3 divided by 6x minus 4. Here also x is not equal to 2 by 3. If it's 2 by 3, its denominator becomes 0. Therefore, x is not equal to 2 by 3. Show that f composition of x is equal to x for all x is not equal to 2 by 3. Then what is F inverse? Yeah, that is F inverse. We have to find F inverse. Here F naught F of x is equal to x. First we find F naught F, which is equal to f of x. Here f of x is equal to 4x plus 3, 6x minus 4. Here f composition of f means here two functions are same function. F is composition with f itself. Two functions are same functions here. F of x equal to 4x plus 3, 6x minus 4. We substitute x value in f of x itself. Therefore, we write 4 into x. We substitute x value at 4x plus 3 divided by 6x minus 4 plus 3 divided by 6 into 4x plus 3 divided by 6x minus 4 plus minus 4. We simplify this. Here Multiply 4 into 4x plus 3. 4 into 4, 16x plus 12 divided by, here denominator is 6x minus 4. We multiply 6x minus 4 into 3 to denominator should be same 6x minus 4. Therefore 3 into 6x minus 18x minus 12. Here also divided by, here also 6x minus 4 is the denominator. 16, 24x, 18 minus 24x plus 6. Here, this denominator cancel. Then we get 16x, 12 cancel. Here 24x cancel. Here 16x plus 18x is equal to 34x divided by, here also 18 plus 16 is equal to 34 is equal to x. Here composition f is equal to x. F composition of f is equal to x, which is equal to identity of the element x. We put the value here x. We get here also x. Therefore, we get f naught f composition of f is equal to x. Then what is f inverse? Therefore, f inverse is equal to f inverse is equal to f itself. The same way, you can find other problem also. Here, we given here is f composition of f itself. Therefore, we put the value same f of x here. We get f of f composition of f is equal to x. Then f inverse also f itself. In this chapter, one is 5-mark question asked in the annual exam paper. Here only 4 or 5 problems are there. You practice well, you can get 5 marks easily. Here 2 methods are there to solve this problem. I solved this problem by 2 methods also. Show that one question. Show that f is a function from -1 to +1 to r given by f of x equal to x divided by x plus 2 is 1. Find the inverse of the function f from -1 to +1 to r means range f. Here solution, we find 1. The function is 1. First we show the function is 1. We select 2 elements from domain. Let x1, x2 belongs to domain of F. x1, x2 belongs to domain of F of x1 is equal to f of x2. You already know about it. F of x1 is equal to x1 divided by x1 plus 2, which is equal to x2 divided by x2 plus 2. Then x1 into x2 plus 2 is equal to x2 into x1 plus x2 into x1 plus 2. We multiply this one, x1 into x2 plus 2x1, which is equal to x2 into x1 plus 2x2. Here x2, x1 into x2, two sides are to cancel. 2x1 is equal to 2x2, then x1 is equal to x2. x1 is equal to x2. F of x1 is equal to f of x2 into, then x1 also equal to x1 is equal to x2. The function is 1. The function is 1. We show the function is find the inverse of the function. In this part, we select an element from range codomain. Yeah, it's a domain, it's a range. We select any element of y. We find the pre-image in the domain. Every element of y should have, if having a pre-image in x, then it's a quantum function. We find the function is 1. Next step. Let y, which is belongs to y or domain of f or range of f. Yeah, range of f. Then y is equal to x plus x bar x plus 2. Y is equal to f of x equal to y is equal to f of x. Then x is equal to y into x plus 2. X equal to xy plus 2y. X minus yx is equal to 2y. Then we find common, take common x, 1 minus y is equal to 2y. Therefore, x equal to 2y divided by 1 minus 1. X equal to 2y divided by 1 minus y. For all y belongs to range f, there exists. The symbol is there exists an element x belongs to domain of f. We simply write it as for all y belongs to range f. For all y belongs to range f, there exists x belongs to domain of f such that f of 2y divided by 1 minus y, which is equal to y. Then we can show that f of 2y divided by 1 minus 1, which is equal to here 2y divided by 1 minus y divided by 2y divided by 1 minus 1 plus 2, which is equal to 2y divided by 1 minus 1 into 1 minus 1 divided by 2y plus 2 minus 2y. Here 2y gets cancelled. 1 minus 1 gets cancelled. 2y divided by 2. Here is 2. 2 cancel. It is equal to y. Therefore, we write it as f of 2y divided by 1 minus y is equal to y. Therefore, the function is inverted. It's I1. The function is invertible with this function f not f. Then the inverse of this function f inverse is equal to inverse of x is equal to 2x divided by 1 minus x. If we write here x, we write the inverse also in the terms of x itself. If we write f inverse y, which is equal to 2y divided by 1 minus, don't forget here. If you write x here also you have to write x. If you write y, here you have to write y, because the unit and pre-images with respect to them. With respect to them. If we put x, we get 2x 1 minus. If you put y, you get 2y divided by 1 minus 1. This is the function is 100 counted and the inverse also there, that is f of inverse y is equal to 2y divided by 1 minus 1. In the next class, I will discuss some more problems on this type because it's very important question, because it's 5-mark questions every time asked in the annual question paper. Therefore, you practice very well and sometimes you follow the alternate method also. I will discuss once again 2 more problems in the next class. Thank you.